Relation of the Pyramid of Giza. The team is composed of Victor, Miguel Angel, Karen, Olivama, and I, Mariana. Overall objective: manifest by means of the Pythagoras theorem and cosine law the calculation of the measures of the pyramid. Particle target: the calculation of the pyramid of Giza for the location of its site and English. For everyday problems to gain the theory, Pythagoras and cosine link.
Introduction. To better understand Pythagoras' theorem, one must go from its origins. This theory begins from the 6th century BC by the Greek philosopher and mathematician Pythagoras, who showed that in every right triangle the legs of the hypotenuse is equal to the square root of the sum of the area of the squares of the respective legs of the legs. It is the best known proposition among those with their own name in mathematics. But it is estimated that it could have been prior to its existence, or it was under another denomination. Since previous in the Mesopotamia and ancient Egypt, the values corresponding to the side of the right triangle were known, and it is used to solve problems related to the Pyramid of Khafre, dated in the 26th century AC, was the first Greek pyramid that was built in the so-called Egypt's sacred triangle of proposition 3, 4, 5.
Problem statement. Taking into account the rough measurements of the Pyramid of Giza and considering that this is an equilateral triangle, calculate the measurements of its interior angles as well as that of its sides. Of the following Sarah shown in the figure. Sarah, base 230.36 meters, height 146.7 meters, angle 90 degrees. For calculated angles, we need to divide the triangle in half to get two right triangles. Then we can obtain the hypotenuse. So we are going to use the Pythagoras theorem that says that c squared is equals by squares plus a square. So we are going to use 280.36 meters base and divide it into 2, that will result in 115.18. Some of the trigonometric ratios, and for this case we are going to use cosine of theta, that it is adjacent leg divided by opposite leg, that will result in 51.8631 degrees. And to calculate another angle, we will do the same procedure, and it results in 38.1368 degrees. Then we will join the right triangles and multiply the third angle by 2 to obtain only one angle. And these are the measurements of the Pyramid of Giza. Question number 2. Taking the following figure into account, calculate the hypotenuse of the shadow that the pyramid reflects. So in this case, we are going to divide the triangle in half again, and we have only the base with 115.18 18 meters, and the height with 153.07 meters and an angle of 19 degrees. Here we will use the Pythagoras theorem to know the hypotenuse. We are going to multiply 150.18 square plus 153.07 square. That will result in 36,696.8573 and take the square root of the result.
Group conclusion. In conclusion, King of the Pythagoras theorem contains law the conclusion of area and volume in essential for problem solving. This time we could conclude that since ancient civilizations formulas were needed. In this problem, we could notice that trigonometric calculations are occupied in ancient wisdom if you want to know some property of a figure or time. Taking into account the real measurements of the Pyramid of Giza, and considering that it's in equilateral triangle, calculate the measurements of its interior angles and width of sides, counting on the following that are counted in the figure. Find out the missing sides and angles of the Pyramid of Giza. Calculate its volume and area, taking the following figure into account. Calculate the area and the hypotenuse of the shadow that the pyramid reflects. Of areas and volume is essential for problem solving. This time we could conclude that from the ancient civilizations, formulas were needed for the calculation of the their constructions.